Good morning, students, fifth graders at Ida B. Wells Elementary School. I don't know if you remember me. I'm Dr. David Padgett from Tennessee State University. And if you remember, we went outside and we collected some atmospheric science data on the playground. Very cloudy. I don't know. Hope you remember. We were working with Miss Myra Smith's class, the math class. And so I'd like to thank Miss Smith for allowing our students to work with your students. And so now each of my students will introduce themselves, name, major, classification, where they're from, and then they will share the maps that we made using your data. So you all collect the data outside, if you remember that. And then, but now we're going to share those data with you. Okay, so now my students are going to introduce themselves to you all.
Hi, I'm William Young.
No. Camera's right there.
Hi, I'm William Young. I'm a business major. That's what it is, and I'm going to study.
Next. Camera.
Hey, I'm Chris Benson, the freshman psychology major from
Next.
Hi, my name is Melina Lambert. I'm a freshman mass communication major from Memphis, Tennessee. Hi, my name is Chloe Jones. I'm a biology major from Memphis, Tennessee, and I'm a freshman.
Okay, so I'm going to share the screen now. And we're going to jog your memory a little bit. Okay, so if you students remember, we were outside, and this is just some photographs of you all when you were collecting the data last week. See, you might recognize yourself getting those data. I wanted to remind you in case you need a reminder. Here's another one of the students with my students. You all did a great job last week collecting the data. So what we've done is we've taken the data that you collected and we've made some maps out of the data that was collected last week. You all remember, you all did a really good job. Good job out there. And again, thanks to your math teacher, Miss Smith, for allowing me to work. Now, my students are going to come here and they are going to show you the map that was created. Okay, so here is the map. And so we're going to have Miss Lambert come up first and share some things. Okay, so Miss Lambert, notice that the students' names are, can you read the students' names for the data that we have?
D'Antoine, David, Jeremiah, Jacob, Jaden, and Casey.
Yes, so next, Lambert is going to is going to zoom more closely in on the schoolyard first. Okay, and now let's click on Jeremiah's data. Looks like it's that green guy. Well, actually, that's Jacob's data. Well, Jacob's data and Jeremiah's data at the same place. So either one, it doesn't matter. So just, can you share with us some of the data that Jacob collected in terms of the share, what was the data that Jacob collected there?
Okay, so Jacob, it seems as though you're, where you were on the upper grade playground. Your average surface temperature was 27.10. Your current temperature was 22
Miss Lambert, is
Sir.
that degrees Fahrenheit or degrees Celsius?
Celsius.
Yes.
The land cover you had recorded was concrete. Your latitude was 36.18 and your longitude was negative 86.77. The total cloud cover percentage was 90. The sky color that day was milky and the sky visibility was very hazy. There were no contrails, nor were there any high level cloud types, but the mid-level cloud types was altostratus. And the low level cloud types was stratocumulus, and the wind speed was 1.30.
Okay, so now Miss Jones is going to come up. Thank you very much, Miss Lambert. So now Miss Jones is going to come up and continue with the presentation. So Miss Jones, can you show us perhaps, okay, now we have Jeremiah's data.
So this data was taken again at the upper grade playground. The surface temperature is 27.1. It's 23.10 degrees Celsius, both these are degrees Celsius. The land cover was concrete. The latitude was 36.18, longitude of negative 86.77. There's a total cloud coverage percentage of 90. The cloud color was milky and visibility was very hazy. There were no contrails or high-level clouds. The mid-level clouds were altostratus, and the low-level clouds were stratocumulus, and the wind speed was 1.30.
Okay, let's look at those temperatures, surface temperature and current temperature. Can you go back? Let's look at the other data. Let's look at Jacob's data. So it looks like Jacob's data was just a little bit different than Jeremiah's data. Go back to Jeremiah's data. Yeah, so they both got the same surface temperature, but their current temperature was just 1 degree Celsius different, which still you guys did a good job collecting the data. But now we're going to show you what this map can do. And so we're going to have Mr. Young come up and we're going to do some more interesting things with this map. Thank you, Miss Jones. And so now, Mr. Young. Buttons on the side. Yeah, okay. Okay, so just minimize that the dialog box. Okay, so now what Mr. Young is going to do is he's going to show you the difference in your data. So he's going to go to content, and then he's going to go to that first layer. So this is the layer of the map that contains your data, young people. He's going to click on change style. Yes, yes. And he's going to change that from Ida B. Wells Elementary student to average surface temperature. And now we're going to go to, let's go to options, symbols, change the fill to a red color. A nice red color, hit okay. Okay, that's good. Now hit okay in the legend box. And then hit done. And then go back to legend. Okay, so Mr. Young is now going to describe what you're seeing on the map in terms of the differences in the surface temperature observed.
So currently, it looks like in this area, or who this was, it was 27 degrees Celsius, I believe, right? And it goes down to 25.7 degrees Celsius. I don't know. I think that's this person, which is, I'm seeing
That's David.
David. So, yeah, David, you had a 25.77 degrees Celsius average surface temperature. And the highest was the 27, which was Jacob. So Jacob, you had the highest degrees Celsius.
Okay, so let's okay, so we see that map, and so let's see if there's a difference between what we see here and the current temperature.
So right now, go back to
Yeah, you have to click on any of the symbols. And so, yeah, so he's gonna go to content,
and we go here.
and then you're gonna change that from average surface temperature to current temperature.
Okay, color.
No, just leave the color just like that. Hit done. And then go to legend. So, okay, now Mr. Young is going to describe the differences in the various
Here.
data points.
Okay, so as you zoom in, current temperature right here. This would be, what is this? This. The highest was 23.1, and then the lowest was 20.5.
Degrees Celsius.
Celsius, I'm sorry, I got it. But I'm trying to see who it was. I believe it was David, who also has the current temperature that was the highest was 23 degrees Celsius, and then the lowest was 20.5 degrees Celsius, which I believe it was Jaden. Yes. It was Jaden that had that. So Jaden, you had the lowest degree Celsius.
So even though there were differences in temperature, all of you all did a very good job. Now, Mr. Jones is going to explain to you how to convert a simple conversion from degrees Celsius to, well, actually, I'm gonna do it. So let me step in here just for a second. Good job, thank you, Mr. Jones. So all of you all probably know how to measure temperature in degrees Fahrenheit. But we were using metric units here. And so we have to use those units because everybody else in the world uses metric units except for the United States. So sometimes we have to be able to convert between the two. So so write this down. Give you a moment to get a pen or a pencil out. Now, this is a math class. So here's what I want you to do. Okay, first, we're gonna do an approximation. Write this down. 10 degrees, well, let's go 0 degrees Celsius is about 32 degrees Fahrenheit. Okay, write that down. Okay, next, 10 degrees Celsius is about 50 degrees Fahrenheit. 10 degrees Celsius is about 50 degrees Fahrenheit. Write that down. 20 degrees Celsius is about 70 degrees Fahrenheit. Close to that. Write that down. Now your math assignment is to tell Miss Smith, she's going to show you how to do the conversion. What is 30 degrees Celsius in degrees Fahrenheit? That's your math assignment for after this presentation is over. And then Miss Smith is going to tell me, you know, which one of you all answered that correctly. And you should also, as an extended lesson, figure out how close our approximations are to the actual temperature. So remember, 0 degrees Celsius is about 32 degrees Fahrenheit. 10 degrees Celsius is about 50 degrees Fahrenheit, but is it? Might have to do some math. And 20 degrees Celsius is about 70 degrees Fahrenheit. Remember, I said about. So you might have to do some math. And then your math assignment is to figure out the Fahrenheit equivalent for 30 degrees Celsius. Okay, so that'll be after we're done here. We have one more thing to do, and we're going to bring up my last student, Middleton, and he's going to show us some more things on the map. So Middleton is going to come up here, and okay, here is Mr. Middleton. He's going to show you some more interesting things about your data. Okay, so Mr. Middleton is going to go to content, and then he's going to click on that layer, that first layer. He's going to go to change style, and he's going to change the attribute to, let's see, I think we had some, let's go to middle level cloud types first. Mid-level cloud types there. So this is going to be a graphic. Hit done. And then hit legend. So Middleton is going to discuss the cloud types that we noticed on that particular day. So just click on any of the dots that's student data. Okay, so that might just slide that, yeah. Okay, so here we're back at David's data. So what kind of clouds did David observe? You have to scroll down.
From what I see, David recorded a mid-level cloud type of autocumulus, and the other 3 students recorded a cloud type of stratocumulus, which was the only 2 cloud types students probably saw that day.
Well, let's look at that again. Which student is this that we're looking at now?
Jacob.
So Jacob, and what mid-level cloud did Jacob observe?
Stratocumulus.
Okay, and now click that arrow at the top. See right there. Let's see. So this is, who's this? Jeremiah, he has altostratus. And go back to Jeremiah. Okay, they both had alto stratus. And so let's look at somebody else. So we have some agreement. Let's click on another point, data point there, that one. Okay, this is Jaden. So what did Jaden? Alto stratus. And then let's see, who's the last person? We already, that's David. Scroll down. Oh, this is Casey. Can't leave the young ladies out. Alto stratus. No, so some of the so some people got alto stratus and some people got alto cumulus, and it is possible that both of those are correct. Go back to content and go to the you click on that layer again and go to there. Change this to low level cloud type. See what we got here. Hit done. So apparently in the legend, somebody didn't see any low level clouds, which is interesting. So just let's see who didn't see any low level clouds. Casey said she didn't see any low level clouds. Yeah, Jaden didn't see any low level clouds either. What about the other two people? Or the three people? See, you can click across and see. Yes, so Jacob saw stratocumulus low level clouds. Okay, then the last person was David. Let's see what David saw any low level cloud. Now his yeah, let's see the blue dot. You click on it, yeah, the blue dot. That's David. So David saw stratocumulus also. So it's very interesting. So who's right, who's wrong? Well, I think you could both be correct. It's possible for everybody to be correct here. I personally, I don't want to make, I saw some low level stratus clouds myself, but that's just me. All right, thank you very much. So now we're going to go to a different map. So this is the map that we use to create, well, we use your data to create just like the other map, except this is a different kind of map. This map is going to show us some different things about your data. So let's have Miss Lambert come back up here again. Okay, so Miss Lambert is going to click on the northernmost point. Yes, that one. Okay, so Miss Lambert is going to tell you all what the surface temperature was for some of your data.
So the average surface temperature that was recorded was 27.5 degrees Celsius.
Okay, and then what was the air temperature, the current temperature? You have to switch to.
Oh.
Yes, yeah. It was right, you were right. Change it to air temperature.
You need to have the average temperature. The daily average temperature that was recorded was 22.0 degrees Celsius.
Okay, so if you all remember, the daily average temperature, you all use those thermometers. Remember the blue thermometers that were dangling from the string and the ones you had to read? That's how you got the current temperature. And remember go back to the surface temperature. So the surface temperature, you determine using the red infrared thermometer that we pointed at the ground several times. And then we had to convert those data into degrees Celsius from degrees Fahrenheit. Okay, so Miss Lambert is going to give you a math question based upon the difference between the surface temperature and the current temperature. So she's going to give you a little math assignment. Based upon the difference between the current temperature and the surface temperature that you all determined.
Oh, I'm bad, I'm so sorry. So 27.5 degrees Celsius minus that, minus this 22 degrees Celsius.
Okay. Okay, so that you went a little fast, Miss Lambert. Could you kind of slow down a little bit?
So the math equation that you will have will be taking the average surface temperature, which is 27.5 degrees Celsius. And subtracting this from the daily average temperature, which is 22.0 degrees Celsius.
Okay, thank you. And so Miss Smith will have you all determine the difference between the temperature that was up here with us and the temperature that's on the ground. And Ms. Lambert, could you go back to the surface temperature? And what kind of surface were we measuring the surface temperature? What kind of surface was it?
So the surface cover type was concrete.
Yes, concrete. And so even though it was, we had, go to clouds. So open that satellite matching. He says open a new window. It's right below there, maybe hopefully it's there. Okay, well, in any case, we had a 90% cloud cover, but there was still enough radiation. Look up that word, radiation. There was enough radiation that the concrete was still warming up the air by a certain number of degrees Celsius. And then another math question for you is to figure out how many degrees Fahrenheit warmer the concrete is than the surrounding area. How many degrees Fahrenheit is that concrete warmer than the surrounding area? So now Miss Jones is going to come up, our last presenter. So Miss Jones, what is your major?
Biology.
So Miss Jones wants to probably be in the health science field a little bit, right? So Miss Jones, why should we be concerned about the fact that the concrete makes temperatures hot? Why should we be concerned about it?
And that contributes the, what's it called, the urban island thing.
Well, that's a big word for fifth graders, Miss Jones. Why don't you? What happens what might happen if the temperature gets hotter? What might happen in terms of our health and our breathing? How might that affect us?
Make it worse because the air around it would be hot.
Especially for children who have what? Yes, say that a little bit louder.
Asthma.
Yes, that hot concrete could make temperatures in the summertime hot enough so that people who have asthma might have problems. And also maybe your great grandmothers might have a problem, and great grandfathers might have a problem also. Okay, so I'm gonna have all my students squeeze in front of the camera here. Maybe we might, maybe, I don't know. All my students are gonna squeeze in the camera in the frame here. Maybe kind of dip down. Okay, say goodbye to our students. Thank you very much. Do well, keep doing science. And maybe we'll see you up here like these TSU students in about 10 years or so. All right, thank you very much. So thank you again, Miss Smith, for letting us work with your students. And if anyone has any questions, if any of you students have any questions, you can text me, text Dr. Paget at 615-258-3657. 615-258-3657. Or maybe you should have Miss Smith text me the questions. Yeah, just have Miss Smith text me if you have any questions. All right. Happy belated Earth Day. And hopefully we'll be back again soon to do some more science, maybe later on in the school year. Grade 8.